Okay. All right, let's continue. So how can I use my from this spice simulation we can calculate VTO, gamma, KP, and lambda for hand analysis. Okay. Then here we want to calculate GM and RO. This GM is just a transconductance. So GM equal drain current divided by what? Gate voltage. This RO is drain current divided by VDS. So here my VDS is constant. My VBS equal constant, right? Constant. Here my VGS is a constant. My VBS is a constant. And then should be just inverse of it. My intrinsic voltage gain, small signal voltage gain is GMRO. Right? So let's see. Let's try to calculate the GM. How can you calculate the GM? From SPICE. Yeah, I want to calculate the GM. See, something like, yeah, this is some drain source voltage, right? Drain source voltage. And then I have some voltages also, zero voltage also there for monitor current. So I apply some voltage like 0.4 volt here. And then I have another transistor. The voltage is like 0.401 volt. And then 0 volt for current monitor, and then same VDS. Okay, this is connected there. Okay, I will change this one. So I can calculate this I1 and I2, and then my GM is just I2 minus I1 divided by 0.001 volt, right? That's my GM. Okay. So let's look at the SPICE code for that. Where is my GM? Oh no, open. Oh, there is no GM, just GM RO thing, everything together. Let's just see. Oh. How come I don't have any GM thing here? Oh yeah, here. So here, see, yeah, I have how many transistors? 6 transistors here. And then it's a gate voltage 0.2, 0.3, 0.7. And then I have another group of transistors here, all the same, except gate voltage is increased by plus 1 millivolt here. And then, say, to calculate GM, I use a, what? This H thing is current controlled voltage source. It means the current of this voltage source VMN1, which is I think I1. Yeah, it's yeah. Then this current is converted into voltage drop across these two nodes, GM12 and 0. So the voltage drop between GM12 and 0 is the current of this voltage source Vmn1 times minus 1000. Okay, and then I have for the other current source, which is I2. This I2 is multiplied by 1000 and then reflected as a voltage drop between GM11 and GM12. So this is same GM12. See, if I plot GM11, that's this current minus this current times 1000, right? This itself is the value of GM, okay? So if I plot this voltage of GM11 node voltage, that's my GM, okay? Question. This is just, related to your homework 1. Oh, no question? Okay, let's simulate it. So we opened it and then simulate it. Well, it takes some time. Okay. Oh yeah, here. Yeah, this is my GM. For gate source voltage is 0.2 volt. Yeah, this one is drain source voltage. You know, this is drain current. Sorry, this is GM itself, and this is GM for VGS equal 0.7 volt, 0.6 volt, 0.5 volt, 0.4 volt, or something like that. Okay, that's my GM. Question? No? Okay, so if you don't have any questions, let's move to GMB. Yeah, GMB can be calculated similarly. What's this thing? This thing I wanna. Okay, this is GMB thing. Oops, wrong. Oh yeah, here. So that's a GM. I used current controlled voltage source here, right? Okay, how I can do it similarly for the GDS. GDS is one of RO. Okay, so let's just see. Oh yeah. See, I just compare the current of these 5 transistors, and then I apply. Where is it? Oh, here. I have the same 5 transistors, different nodes, and then I apply a VDS larger than by 1 millivolt by adding this current monitoring circuit by minus 1 millivolt. Then this thing becomes, say, I'm changing my VDS, right? I'm changing my VDS. And then this node, this NLD1 node is the drain source voltage is larger than this ND1 node voltage by 1 millivolt. So I compare this current with ND1. This ND1 is here. Current of VMN1, and then I compare this current of this voltage source VRMN1. So then similarly by using voltage controlled current source, right? So let's see, where is it? Uh-oh, how come I have too many plus? Okay, where am I? Yeah, so it's here. Oops, oh no. Looks like it's closed. So my GDS is here. This is a point GDS for a gate source voltage 0.2 volt, 0.3, 0.4, 0.5, 0.6, 0.7 volt, right? So I have my GDS here. This is the drain source voltage. This is the GDS, right? So if I plug low flux, so this is my GDS at the 0.7 volt gate source voltage, 0.6 volt, something like that. Okay. So I have a GM and the GDS. I want to calculate. Okay, question until now. I just subtracted two current by converted into voltage by using current controlled voltage source H, and then subtract the two voltages, right? Then I could calculate the I1 minus I2. Okay? No? Okay, let's try to calculate GM divided by GDS. That's my GMRO, which is my intrinsic voltage gain. Okay? So how can I do that? I used some trick. Let's see, what kind of trick is it? Oh, I use diode. See, I want to divide. Yeah, until now I have just a subtraction, I1 minus I2, right? But now I want to divide GM by GDS. GM divided by GDS, right? Then, what kind of trick is it? I use the diode. You cannot see it pretty well. Or I cannot increase this screen size. How? Huh? How come I cannot increase it? Oh, no. Can I enlarge this one? Nope, nope. Okay. No. Oh. I cannot increase the size of this one. Okay, let me write it down. Yeah, this is a little bit complex, but I use the diode for multiplication. So I use the voltage controlled current source G, and then I converted that thing, I applied that current into diode, and then found the voltage drop across diode, and then that that voltage is subtracted. Is it subtracted? Yeah, subtracted by using voltage controlled current source. So how can I do that? Let's see. Yeah, let me copy this thing. Yeah, here. Oh yeah, now I can find it. Okay. Okay. So how I want to calculate GM divided by GDS, right? Which is only GMRO. This is intrinsic voltage gain. Then let's see. Yeah, this is voltage controlled current source. Okay, the voltage of this one, this node voltage, is this node voltage? Yeah, it represents a current, right? It was generated by H. This is a current controlled voltage source, right? Which is actually I1 or something like that. Okay. The voltage drop across this GM11 node and ground is just I1. Okay. And then this thing is converted into voltage. This is voltage across this node. So I just this is a 0 node, and then my I1 is applied like that. Is this right? 0. Oh yeah, something like that. Oh, sorry. This should be current, right? 0 to 1. Okay. So my current is sorry. This is not voltage. This is current. So I just converted my I1 value from this voltage into current here. It flows through IGM1, flows out. Okay, I apply that into diode here, which has this IV characteristic is I equal IS exponential V NVT minus 1. Okay, this is my diode, right? So this current is converted into this voltage drop. So my V equal, actually there is some multiplication here. So my current is actually 10 to the 9. So my voltage is NVT, N is just 1, log I of IS plus 1, right? Is this right? Okay. So I want to make this one much larger than 1. So I increased my current value by this huge amount, right? My IS is still large, it's very small. Then this V is proportional to log I1, right? Then see this voltage, this is this current. So I do similar thing for I2 here, and this is a voltage controlled voltage source, right? So this what is this thing? This gain is 1. This is what? Let's just see. This is output current, right? So actually, this is okay. The first thing is this node voltage is what? And this node voltage, I should subtract it. GDS, actually, I2 is, this is GM1, actually. This is GDS. Then this is NVT log GM over GDS. This is what I wanted, right? So let's see, I need another exponential. So I apply this voltage into diode and then get current, right? Is this current? Oh yeah, this is a current monitoring voltage source. So this voltage is converted into this is a current controlled voltage source, right? This voltage. So let's see, this is some conversion factor. So actually this node voltage is my GM over GDS. Question? No question? Yeah, this is your homework. Repeat this one for GMB over GM. This GMB is actually what? Yeah, you can calculate the GMB by applying one thing is VB, one thing is VB plus. So this is I1, this is ID2, ID1. So your GMB is just I2 minus I1 divided by 001. Okay? You can do same thing. And then you already know your GMB. So you just plot your GM over GMB or different values or something like that. Different values of VGS1, VGS2, something like that. Repeat the above procedure. Okay, question? Okay. Let's just